Before we go to Fusion and I show you how we can now and recreate our concept model or our study that we created in Blender and now create a more industrial strength geometry which can be used for manufacturing, I would like to go back to Blender for 1 second and show you something I didn't show during class. So what you see here is kind of like a final concept model. This is not the one for texturing. This is just the one where I'm exploring maybe the shapes. And this is also not the one that uses the bend modifier to deform it. The main reason was simply to be more complete. For the bend version, I showed how we can cut this space out instead of modeling it. And in the exercises or the steps before, we always try to model these openings by hand. However, we can actually approach this the same way. So here is a very basic model. So you see the shape is very simplistic, and I used the bevel modifier to round the center and the corner edges. And then I, via this object where I can define the roundings, can then via the Boolean and difference in B mesh cut actually the space out already out of this very basic mesh. There we, for example, tried to model this by hand, and we ran into the issue in how can we round this corner, which with polygons in that case is simply not possible. But the advantage of polygons is ideal here with a very basic geometry. I can quickly, for the sake of creating a study geometry, manipulate it and play through ideas or proportions before I go into the more accurate CAD environment. So, and then this surface, you can see, I simply can add then the solidify modifier to give it a thickness, and then for example here on the last step, then I added the fillet for the rounding, and in addition I trimmed the bottom area. I overbuilt the bottom area a little bit, and I created a box at the bottom, and this box I will use via another Boolean modifier and B mesh and difference and cut the bottom area at the end off. So there are two things here again I wanted to point out. If it's a very basic surface, even that one we can cut the space out already, which is exactly what we will do in Fusion. And then to this result, as we also will do in Fusion, we will create then the thickness. I could obviously also add the thickness and then to this result cut the part out. In Blender currently this works left pocket, right pocket. It doesn't really matter, because what we will use to cut the space out is actually an object like this. Now in Fusion we will do something similar. I will make a copy of this one, and then I will rotate this one to there. I will turn this one off. I will bring this one along X to the 0 point, and then this surface I stretch out a lot like this. Okay, so let me put this one maybe to there, and let's say this is actually a lag tunnel, so I know the name. And you know, we have first the solidify modifier and then we cut the lag out. So let's here in this case now use the tunnel. Same thing, pretty awesome and easy. The advantage is now you see I can manipulate just a big surface that is intersecting the whole leg area. And that is kind of like what I will show you in Fusion in a similar way, but there is just one problem. When we take a look at the cut is horizontal, and that is not really what I want. And that is why in Blender, as well as in Fusion, and increasingly you will start seeing how I work in both programs exactly the same way. Basically, I work in Blender more in a way that's compatible with Fusion. I have to cut the opening first, and then maybe I can pull this out. But now see, there we run into some issues, which is why I actually use those legs here and there. Ding ding, and then it's cut out, and then we can do the add the thickness to it. Because traditionally Blender or polygons in general here can have an issue, as you saw with opening this out of a flat surface. It is easier when we do volume manipulations to just in general work with volumes to cut out of not a flat surface, but for example better a volume itself. And then it honestly doesn't really matter how we cut it. Okay, so let's go to Fusion and I will show you how we will build this. Let's make a new design. Let's set this one to centimeters, so we have exactly the same dimensions, and we will recreate everything we did in Blender exactly the same way. So in Blender we created a plane, moved it up, and then we extruded the legs out. So we did some direct modeling. That in this case doesn't work with NURBS geometry at all. We need to create first a sketch so we have the lines we could extrude along. So in front view, or click on the create new sketch, you want to make a sketch that is not on the ground, but actually, if I click onto front, on this vertical yellow rectangle. Then let's zoom out a little bit. Okay, and then now we can create exactly the same structure. So for example, I will snap here to the grid, go to there, go to there, and then snap maybe to there. Okay. And now we have to dimension everything so we know that we have exactly the correct proportions, for example. So we could, for example, press D or go to sketch and then go to dimension, and then we say this point to this point in my world center be this distance. So at the bottom, from left to right, this should be 52. So this would be 26. It's half of it. And this is also dimension 1. You see when I put my mouse onto it, you can see the value. So let's do the same, this point to this point there. And now I could type in 26. But I want this to work like the mirror modifier. So I will double click this value so I get the edit mode, and then I can click this dimension. And you see it types in then D1, and when I press enter, it uses then the correct value, and this one moved a little bit. Not a big deal. So what's happening is the sketch solver tries to figure out, well, how do I want the sketch to be manipulated, and I do not want this point to be going down, I want this one to be horizontal. But with the sketch solvers, we need to restrict movements as much as possible. So this point and this point, they should always be horizontal. So you and you be horizontal. Okay. And you see that when I undo this one, I move this one a little bit to a horizontal position. If I move this one to below, then it might more think that I want to have a vertical constraint. Okay, so horizontal, I could also say U and U, horizontal, there, perfect, good. And I could also say, well, this point to the center point be horizontal. And now because these 2 points are to each other horizontal, and I made this point horizontal to this world center, the other one will always be horizontal to the world center in addition. Good. So now I have this line here, which I can move around. There I can move this point a little bit. So I would like to adjust the height. So I press D, click this point, can click this point, go to the side, and there I can type in 45. That is, for example, the height. Okay, perfect. And maybe here on top, I would like this to be 40 centimeters. So you see I'm also able to click, for example, this line. Okay. So how do I, for example, center this line over here? So I could do a small trick. I will create a point directly at the midpoint of this edge, which is there. And then I try to move this one a little bit closer, so it's vertical over the world center, and then I say vertical constraint to there. And now, because the point is vertically constrained to the center, and the point is constrained to the midpoint of the line will follow wherever the line is, the point is. Okay, so this is good so far. Let's say this is our basic sketch. The problem, however, is up here, this is a line. That's not really what I want. So I could, for example, also delete this line. And let's say I delete the point, and I also delete this. Okay, so I can also specify the dimension simply between 2 points. Let's say like this. So this should be 40, and these 2 points should also be horizontally at the same position. So now you see I can slide those left and right, but I can't really move them up and down anymore. Okay, so here we have a small arc. So how do we do this? Well, we could go ahead and then go to Sketch, go to Arc, 3-point arc, so left to right, and then, for example, here's my arc. And I click here on the snap grid, and if I zoom out now, up here when I press Escape with a mouse, and I can select the center point of my arc. Now this point I want to be vertically constrained to the sketch center there. So now I can select this point, and I can't really move it anymore. I can only, for example, move this point maybe up or down if it allows me to do that. No, it doesn't. It's fine. That basically adjusts the radius of the arc, and you see I can actually push and pull the arc. So the arc is a perfect circle if we would close it. So we can dimension it with D and give it a radius, maybe 60 or maybe 50, 40. There you see the different changes. Whoa. Just be careful, don't give it too much. Okay. Good. So this is a little bit similar to the geometry-wise, kind of like what we did in Blender. And you see now here we created this arc, and then there we want to create the rounding as well. Well, we could go ahead and, for example, create a fillet. And there's our fillet. But the problem, as you can see, is a lot of my dimensions go away, and I also do not have this very basic line work anymore. So that's actually not ideal, which is I try, if I don't have to, I will not actually fillet the sketch. I will keep the sketch very simplistic, so very basic. So later I can easily, by double clicking these numbers and give this different values, adjust then my sketch. So the same methodology I apply in Blender to try to work with very basic geometry, I do here as well. It's always, and basically no matter what CAD environment you work in, that's a very good advice. The most basic steps to get your work done. The main reason for that is, again, the less geometry you have, the easier the manipulation happens, and the less stuff can go wrong, and you save simply labor time. So this is good for the moment. So now we can click Stop Sketch, and the whole stool is 40 centimeters left and right. So we can go to Patch Mode. This is now where we have all the surface tools. There is Extrude, and then we can click the sketch and say Symmetry, extrude this one out, and we have to type in 20 because it's symmetry. 20 plus 20 is 40, and there we are. Perfect. So now we can, for example, round these corners, and we go to Fillet, click this edge and this edge, and for example start rounding this a little bit, maybe like this, so maybe a 4 centimeter rounding. Let's zoom in a little bit because in class I talked about G1 and G2, or the radial fillet. Here we have a G2 option to switch between G1 and G2, but I'm still not really madly in love with the result. I want to sculpt this a little bit more. So in this case, this approach is not necessarily really well working, but I can still okay the step, because now, as you can see, the fillet command sliced my object into multiple parts. Now what I want to do is get rid of those faces and then add thickness to those, and then we create or recreate the transition. In terms of technical lingo, these are kind of like considered primary surfaces, and this is a secondary surface. So it's more like a transition. To remove those, we can unstitch them. So this whole mesh currently is stitched together. So with the unstitch command, deselect everything, deselect the chain select, and then we can click this one, and say OK. And then you see here we have 3 bodies, 1 body, and 1 body. These two we can select in the browser with Shift, right mouse button, and remove. Do not delete, just remove. Okay, now we have this very basic layout here of our primary surfaces, and I will go to Thicken under Create, click this one, and this one, and then we say 1.5 centimeters. This is kind of like this solidify modifier in Blender. Okay, there. Now we have our surfaces. So now it's a volume, and now I can say from this face to this face. create me a transition. In Blender, the command would be called bridge, or in T-Spline, it's also the command bridge in Fusion. And in other CAD programs, sometimes they call it then blend. And in Fusion, that is part of the Loft command. So the nice thing about Fusion is they don't bombard you with menu options and different tools. They have everything more compact and have more powerful, less tools. Okay, so we can click OK. You see I had those faces selected. If you have no face select, click Loft, and then I start from the top to the bottom. You see now it creates kind of like a chamfer transition. And then I could say tangent or smooth. Now that's the one we want. We want to have a really nice, good transition. Okay, perfect. There's also here an arrow we can adjust. So we can, for example, play a little bit with this way, click on profile 1, then I can pull this out, and I just, after the primary object, I just want to extend the surface a little bit before it makes the transition. Perfect. So let's set them maybe the same, 1.35 or 1.35. Okay, good. These tangency weights, you see here also we're talking with weight. In Blender I introduced you to edge weight. Here we use basically the concept of applying a weight as well. It just doesn't work on a per edge, but here it works basically on the face and how it weights. So click OK, and now we can go to oh no, we cannot. Shoot, I made a mistake. I was in Surface Loft, which is not what I wanted, so sorry, my fault. Because this is a solid, we actually want to do the same in Solid Loft. And the main reason is you saw that I created the surface, but now this is actually a new object and it's not fused to those parts, which is what I want. So I delete it, go to Model, Loft, and then say 1 and 2, smooth, smooth, and then you reset 3.5, and also there 3.5. Okay, perfect. And now you see here this is just one object. Great. So let's go ahead. We will do the same on the other side. Again, now I picked top down, so let's do the same. And there, and there. So I can now enter the values by hand, but that's not what I want. I want, if I adjust this one fillet on the right side, or sorry, the loft, that this updates the same way. So I would need to know what the different values or names for tangency weight for profile 1 and 2. I think this is probably I think maybe D. No, I would have to see. It's one of the D's. Okay, click OK. So now we can go to Modify, change parameters, open this one. There is Loft 3 and there's Loft 2, and now we have here 13 and 14. Oh, this is actually wrong. So there we want to have 0.35, and you see now this updated. And this is start and end, start and end. So D15 we want to be the value of 1.35 of D13. So here we type in D13, here we type in D14 for the end. Okay, so this is kind of like kind of like mirroring, but instead of mirroring an object, we kind of like create a mirror effect by linking the values. So you see the fillet command or the weight command can have an expression, and the expression basically here means it's the value of D13. Okay, perfect. Good. So now we have our very basic object created. So if we want to style this a little bit, right mouse button click and show dimensions. You can see now we could type in 40 and scale this, everything moves down, or 50, everything goes up, 45, maybe make this 30. So you see, in this case here, to do adjustments, we ideally want to and can only adjust the values of dimensions, which is why we have to create these dimensions. If the sketch is very basic, we could even push and pull certain points, but you notice like with the arc, I couldn't really move the center point of the arc. Sketch solvers like in Fusion or in parametric programs don't really like drag and drop. They rather like the sketch to be adjusted by changing the values of the dimensions. Simply because it's a sketch solver, it on the fly constantly tries to solve how you want to deform the sketch. So we need to create all these restrictions. So all these dimensions are restrictions. And if there are no restrictions, then it will try to deform it best guessing, and sometimes that simply can work, or most times it doesn't work very well, or not the way how you want. Okay, perfect. So if, for example, I want to adjust the rounding, then I could either go, since this is the first feature from which we also copy the values, right click, edit feature. And you see now time-wise the design jumps back to this feature. So the second feature currently is not active, and then there we could all say 0.5 and here 0.5, click OK, and then it rebuilds the whole feature tree again. Or I could go into the change parameters and then, for example, here say, well, 0.2 and 0.2 or 0.4. Okay. So that's the very common aspect to it. And you see, this works very precise, but it's a little bit different than, for example, push and pulling the geometry when you're inside polygonal environment, where we just then only do the conceptual exploration. But that's the whole deal about it. We can use a polygon environment to explore the idea, and then here later we just solidify and finalize and fine-tune that design. We can be more precise, but you see we have to establish a lot more rules, so there you need to really know your design to be able to establish these rules. Okay, so next step, we have to cut this leg out, so we need a new sketch. And we need to be able to extrude, for example, something out. So every sketch, think about a sketch as a sheet of paper, has a front and a back vector. So the sketch for the leg, I cannot draw from here, I have to draw from the left. So new sketch, and for example, I click my mouse not on the object but somewhere next to it, and you see the yellow rectangle is selected. Okay, and maybe here I will hide this for the moment, and for example draw something like this. The main reason why I hid the other elements was simply so that I don't by accident start making a sketch on the object, and then I can show everything. So for example, here in this case, I select this edge, press M, and then I can, for example, move this one up, let's say till there. Okay. This is maybe okay. So I'm just, in this case here, dragging everything. I can select one point and, for example, drag this one over, but then this does not reflect the way how I work with the other one. So let me show you how with the sketch we can do like a mirror command. So we want to establish a symmetry, and for the symmetry I need to have a line. Now in Blender, when we work with the mirror command, we add, for example, an empty, which is our reference, and here we can simply add a line from the center, maybe up or down, doesn't really matter, and this line I will turn into a construction. So it's simply there, but I can't really model with it. It's just a guideline. Now there's the symmetry command, and I can say this point and this point symmetry to this line, this point and this point be symmetrical across this line. Perfect. So now when I start moving this around, you see I can nicely adjust it. So because this is a very basic sketch, this has just some lines. So here during maybe some fine-tuning, I can simply keep this without dimensions, but I already created some constraints or restrictions by the way how I want the sketch to behave. Okay, so this sketch I created, I can now use, for example, to cut a space out of the bent plywood. However, the problem I have is I have already this volume, and if I would do a cut, it would cut horizontally through it. So I cannot do this cut actually at this point. I should, technically speaking, do the cut here, when those are still flat surfaces. So let's see if we can drag this one over to there. And there it is. So you see, this is a very basic sketch. It's not affecting any object yet in my design, so I can, in the timeline, drag it to wherever I want. Left mouse button, click and drag. Let's move the mouse marker also to there. So now in time I went back. Now I can go ahead to patch, modify, trim. This is my trim tool, so it's similar like the Boolean modifier, and it works across the sketch plane. That's the reason why you see this extrusion going left and right. And then I can select this face and this face and delete it. Perfect. Good. Let's go maybe one step further. Let's see if the commands all work, and yeah, they do. Okay, great. See, now we patched in the information about where to cut the legs. And now maybe we can play around with this a little bit. There. Let's say this we like. Perfect. Now we can go ahead into the sketch so that nothing really changes anymore, and add some dimensions. So for example, this point and this point height-wise, this point and this point also height-wise, and we could define how far this is apart, and maybe, for example, clean this up a little bit, 0.5. The dimensions are a little bit unclean, maybe there. And well, this one doesn't matter because it's just basically at a longer angle and it's overbuilt. Okay, perfect. So now we have these sharp corners, and in object mode, in model mode, modify, fillet. There we can go ahead and select maybe those fillets here, and then we can round this, and maybe with a G2 feature add this a little bit. Let's see how this looks now. But this is maybe again not necessarily really what I want, so I would have to maybe work in a different way if I want to have more influence in how, for example, I could style this transition. So this currently is more using kind of like a fillet approach, but I would like to have the same flexibility in styling the transition I did here. So in that case, I cannot just simply use the trim of a very basic sketch. I might have to adjust this differently. So let me show you now how we can create a different transition. The pretty nice part about Fusion with the timeline, it shows you all the different steps you took, and also because it's parametric, we can, as long as it's possible, really adjust a lot inside our sketch or our models, and then the design will be updated for us. So I will delete for the moment all these constraints. And also here, this one, there. Okay, now I will do the following. I will do a fillet. Yes, I know, but hold on. I will do a fillet like this and say maybe 4. Okay, good. Then this line I will delete, and I will draw a line from there to there. I'm just introducing some drawing tools for you. And then we can trim this off because we drew this line. Trim it, press escape, select this line, delete it. Okay, good. Now here is my radius. And again, this is not what I want, so I will delete it. So similar to the surface where I used the fillet to simply create an even opening, I do the same here in the sketch and then just delete it. Before I continue, however, I do not want any of these lines to adjust in any way. So what I will do is, for example, let's say this one should be vertical to here. Okay. And then, for example, dimension-wise, we can specify this one. We can also specify the height. We can, for example, specify the distance this way and specify the distance this way. So it's kind of like a 2D grid. We can specify this if we want, and maybe this and this, and I think no, I can move this one up and down. Okay, and up there, this one you saw got a little bit funky, so I want to make this line horizontal. So now there's nothing I can move anymore. Basically the sketch is secured. And the way how I put the dimensions down is just one easy way. I was just thinking, what are the easiest logical blocks? So I want to specify a distance between these 2 points by along X and along Z. Good. So let's take a look at the Spline command. And then with the Spline command, we can draw from there to there a line. Click the green button. And then there are green handles. For example, we can click on them, and then you see we get some abilities to just deform the spline a little bit. So here we have tangent constraint and smooth constraint. If I click smooth and click this, and then this, I tell the software to make the spline run smoothly into the line. And we can do the same here and here. And then click this point for the handle, M, and then very gently adjust them. Just very small adjustments will have actually quite an impact on how the curve changes. And there. And you see also here, I moved this point up and down, but actually because the handle is constrained to be smooth to the line, the handle adjusts based on the direction of the line. Goodie. Also here, so you know it, we can say point and point have a dimension. And also here, point to point, right click and say aligned, there is a dimension. 0.6 and 0.6, so maybe 0.7. Now here, click this one, copy the value, 0.7. So now when I say 0.8, 1, and you see both sides are updated the same way. Goodie. Okay. The other side is missing. Well, not a big deal. We can use the mirror command in the sketch, and this basically creates copies of these elements and then at the same time also adds the symmetry constraints. So mirror 1, 2, 3 along the mirror line. Okay, and there we are. So if we, let's check, adjust this, and there you see everything updates or not. And notice there's still a problem with the sketch. So I would have to check what the reason for that is. Okay. This might be one of these situations where the software has a problem. I remember there is a bug in the sketch engine. So, however, we will delete this. And this is good this happened, because this I can show you then how, if one doesn't work again, what could be the opposite way. So with the trim command, we basically the software extrudes this sketch along a path and then cuts. Well, I can also build the surface, so I extrude it, and then I use the mirror command for on the surface and build myself the other part. So I only have half a sketch, make half a surface, and then duplicate the surface. So in the end, I get exactly the same result. So most of these commands actually will fail because when we click stop now, here the trim command says, what the heck? And that's because there's not a complete sketch anymore. And that's fine. So what we will do now is patch, extrude, and then symmetry, and we simply extrude and overbuild. So you see these surfaces are intersecting. Click OK. Now we have half of it. Go to create mirror. Then we want this object across this plane. Click OK. Now we have two objects, and these two I would like to stitch together. If we want to be a little bit cleaner, we can also do the following. So these two elements I could either unstitch. Okay, why did I unstitch them? You see these are two parts, so I removed them. And then I say, hey, Loft, uncheck chain, Loft between this edge and this edge. Okay, so it's a line again. Perfect. That was, I had two flat surfaces, and simply I replaced it with a new one flat surface, and then all those I stitch back together, so it's one object. Perfect. Again, what I tried to do was simplify my geometry or reduce the amount to help the software to prevent any interesting misunderstandings. So the trim command is still saying WTH. So right click, edit feature, and it tells you, yeah, nothing works. That's okay, because we have to delete the tool selection. Instead of the sketch, now we select the surface object. And because we stitched it together, it understands this is one big object. And now we can select the surface to trim and then select these two areas we want to cut out. Click OK. There, same result. Let's cross fingers, because the rest actually should work. Ching ching. There. Perfect. So, and then this and this at the end, we can say remove. Great. Nearly done. Nearly. 2 elements left. So let's turn on the origin. And there we can see, if I continue, these legs are not flush with the ground plane. So what I will do at the end, when we are fine-tuning this stuff, press and pull. Instead of adjusting the sketch, I know I can simply extrude these faces via the push and pull, and it switches to the offset command. And when I do this really a lot, you will see that don't go straight down. It follows the direction of the other faces, which is pretty genius. Just a little bit overbuild. Okay, good. Then we can make one last, no, we do not make one last sketch. We can go to modify and say split body. And I want this body to be split by this ground plane. And you see along the disk, it will cut everything. Cut. There. Perfect. And then here we have a lot of new bodies. So 17 is our final one. Shift left mouse button click body 4 to body 16 in my case. Right click, remove, and there we are. Last feature, to add fillet, drag over the whole object. What type of selection do I have? Just drag over it. Ching. Maybe 1 millimeter. There are some corner issues. That's interesting. 0.5. 0.1. Oh, yeah. 0.5 is basically half a centimeter. So yeah, we want this 0.1 is actually a millimeter. So that's the radius maybe we want, because we're in centimeters, so 0.1 is a millimeter. And we can keep this rounding here at the bottom as well if we want. So it's nice and rounded. Or otherwise on the Mac, hold Apple, on the PC, hold the Control key. And then you see now we're in edge select mode. We can deselect these edges. So we get a nice flush ending. But in our case, let's do it this way. There are also some corner types. Can we switch? Yeah. You see, that's a not very good looking type, but maybe this, there we sand also the corner. That looks a little bit nicer. Let's maybe go a G2 so we have a better transition. Okay, there we are. So this is now then the process how we take the information from our concept model and the design intent, and then try to rebuild this one exactly the same way. So we get exactly the same design, but no, our outcome is actually a proper industrial strength quality surface.